Hello, beta. Good morning, everyone.
Good morning, sir.
Good morning. Okay, so beta, recording is on now. The session is on. So yesterday we discussed about the almanac, information available to us in the almanac, and we did some basic calculation that was azimuth using the ABC method and the amplitude. So today we are going to proceed to site solving methods, starting off with Marpas, latitude by meridian altitude, moving on to the other ones, long by Crone, intercept, X meridian, etc. So that's the plan for today. So before I set up the presentation and we proceed ahead, any doubts or queries in your mind? Okay, all right. So we are all set to go into site solving. Let's then start the presentation and go into these methods. These are all done during second mates also. So this is basically a revision, a refresher, how these methods were done. And once we are refreshed about all the 5 methods, then we can move on to the concepts of plotting. That is simultaneous and staggered observations. So let's get into the presentation.
Now, having understood the basics related to site solving or celestial observations,
Sir,
now let's go into the methods with which we can solve the sites.
Go ahead,
सर
beta. Go ahead.
सर किसी ने सर एक डाउट डाला था अभी सर ग्रुप में ये एम्पलीट्यूड का कुछ
Regarding what, beta?
आकाश तुमने डाला था ना
हाँ मैंने डाला था
सर
सर। वो क्वेश्चन नंबर 7 है, एक ग्रुप में डाला है सर।
Okay, let me see. Okay. This is based on rational horizon diagram. Question number 7, na beta?
Yes sir.
Okay, don't worry, we will pick this up. Let us first do these site solving methods. This question is based on rational horizon diagram. So once we are done with these methods, then we will cover this up.
Okay sir, thank you.
Okay, beta. Okay.
And find position lines using these different type of celestial bodies, sun, stars, planets, and the moon. As we discussed earlier also, we have total 5 different methods which can be used for site solving. The first one and the most easiest and basic one is the latitude by meridian altitude, also known as Marpas. The second method known as longitude by chronometer. The third method, intercept. The fourth, X meridian. And number 5, Polaris or pole star observations. So we will now go into these methods one by one. We will see that in these type of questions, what is the information which is provided to us? And how do we use that information to solve the site and find the position line, which can then be plotted on the chart. So starting with our first method, latitude by meridian altitude. Now, as is clear from the name, this method gives us the latitude of the observer, and this method is used when you take the altitude of a body on your meridian. The meridian altitude is also known as meridian passage or Marpas. We are aware that all the celestial bodies, they rise on the eastern horizon. Then after rising, the altitude of the body keeps on increasing, and eventually it comes on the observer's horizon at its highest altitude of the day. After crossing the observer's meridian, the altitude starts to decrease. The body crosses over to the western side of the observer. The altitude starts to decrease and it eventually sets down on the western horizon. So during one complete day, one particular body will be crossing the altitude at one instant. Say if you take the example of the sun rises in the morning, then around noon time, the sun has attained its highest altitude when it is on the meridian of the observer, when the meridian passage or Marpas occurs. And after that, the altitude of the sun decreases. And in the evening, eventually the sun sets and goes below our horizon. So Marpas method is used when the body is crossing the observer's meridian. Now let us see what all information is provided to us in these questions. The information provided is, number one, the date of the observation, the sextant meridian altitude of the body. They will give us the sextant altitude and they will give us an indication that it was the meridian passage. So sextant altitude at the time of Marpas is known as sextant meridian altitude. Then to correct this sextant altitude, they will provide us the index error of the sextant and the height of eye of the observer. This is required for the dip correction. Along with this, they will provide us with the DR position of the ship. We will have the DR latitude and the DR longitude given to us in the question. Now, in these questions, important thing to note is that most of the time, the exact time of observation is not mentioned. In all the other observations which we are going to see, long bichrone, intercept, X meridian, Polaris, you will always have the time of observation mentioned to you, exact time of observation, hour, minute and seconds. But in case of meridian altitude or Marpas observation, the time is usually not provided to us. So how do we obtain this time? We obtain this time from the almanac itself. From the almanac, we first obtain the LMT of meridian passage of the body. So we have seen in the almanac, the LMT meridian passage for the sun is provided to us. Coming to the second body, the moon, again the LMT meridian passage of the moon is provided to us in the almanac. Then for planets, again the LMT meridian passage of planets is also provided. It is given at the bottom of the page. For sun and moon, it is given at the bottom of the right side page, the daily page, the date page. And for the planets, it is given at the bottom of the left side page on the right corner. So bottom right corner of the left side page, you will have the LMT meridian passage of all the 4 planets. So we pick up this LMT Marpas from the almanac and we apply the longitude in time. The dr position is given to us. We have the longitude divided by 15. We get the LIT. We apply the longitude in time and we get the GMT MRPAS of the observation. So we get the GMT time when the observation is taken. Now one doubt may arise at this instant, what is to be done in case of stars? The meridian passage of stars is not given to us. Now fortunately in the case of stars, the MRPAS time is not required at all. Why is it not required for stars? This is because the declination of the stars does not change on a daily basis. It remains constant. So we need this time to calculate the declination of the body. So in case of stars, the declination does not change. It remains the same throughout the day. So the declination can be picked up straight away without bothering about the time of observation. For all the other bodies, sun, moon, as well as the planets, the declination keeps on changing hour to hour, minute to minute. So we require the time of observation for sun, moon, as well as the planets. Now, once the GMT MRPAS is available to us, we can now pick up the declination. The hourly declination is picked up from the date page. Along with it, we also pick up the decorrection value. And we check this decorrection value increment from the increment table. And once we apply the increment, we are able to get the accurate declination of the body. So this is the first step. We obtain the declination of the body. Now in the second step, we correct the altitude of the body. We have the sextant altitude, we have the index error. So we have the height of eye with which we obtain the dip correction. Once we apply these two corrections, we get the apparent altitude of the body. Once apparent altitude is there, we apply the total correction and it gives us the true altitude of the body. Now, the true altitude of the body is named same as azimuth. Fundamentally speaking, the altitude does not have any name. No name is given to the altitude of the body. Now, if the altitude does not have any name, what is the purpose of naming the altitude here? The naming of altitude is done here just as a shortcut method to find out how the true altitude is to be combined with the declination of the body. So as I proceed further, I will tell you the true altitude has to be combined with the declination of the body. So how it is to be combined, whether the figures are to be added or subtracted. So this is just a shortcut method which we are using to find out whether we use a plus sign in the combination or a minus sign in the combination. If we don't use this shortcut method, in that case, we would need to make a rational horizon diagram, which will be time taking and it will make the question lengthier. However, when you are solving these questions for position lines, it is not mandatory to draw a rational horizon diagram. So just to save a bit of time, we use this shortcut method. As we proceed further, it will keep on getting clear to you. Now, once we obtain the true altitude, 90 minus true altitude gives us the MZD. MZD is meridional zenith distance of the body. What is the zenith distance of the body at the time of MRPAS? That is what MZD is. So 90 minus true altitude gives us the MZD of the body. Now the MZD is named opposite to true altitude. Again, I'm repeating here. Fundamentally, MZD, meridional zenith distance, does not have any name. This is just a shortcut method which we are using to save some time in this question. Now, once we obtain the MZD, we already have the declination of the body known to us. So what we do now is we combine the MZD and declination. By combining, I mean either we will add the MZD to the declination, or we are going to subtract one value from the other. Now, how to decide whether they are to be added up or one of them is to be subtracted from the other? This is decided using these names which we gave. You see, we have given the name to the true altitude, same as azimuth. We have given the name to the MZD opposite to the true altitude. So we will now have a name for this MZD, which will be either north or south. Declination obviously has a name. It will be either north or south. Now we compare the names of MZD and declination. If both of them are having the same names, they are added up. And if they are having opposite names, then we subtract the smaller one from the bigger value and we retain the name of the bigger one. So I repeat, if MZD and declination are of the opposite name, we subtract the smaller value from the bigger one and we retain the name of the bigger one. Now, once you do that, you obtain the observed latitude. A combination of MZD and declination gives us the observed latitude for this particular site. This observed latitude is our position line. In this particular case, the Marpas observation, the latitude what we obtain by combining the MZD and the declination is the position line itself. Now, whenever we find the position line, we always denote the direction in which the position line lies. So in this particular case, the direction of the position line is east-west. The PL runs in the east-west direction because this observed latitude is our PL. All the latitudes, parallels of latitude, they run in the east-west direction. So hence the position line which we obtained here is lying in the east-west direction. Now, a doubt could arise in your mind that we have named the true altitude of the body same as azimuth. Now, how to obtain the azimuth of the body? How can we find out what is the azimuth of the body? Now, practically on board a ship, this will not be a problem at all, because when you take the sight of the sun, you take the bearing of the sun, you will be able to easily identify whether it is north of you or it is south of you. When you take the bearing of the sun at the time of Marpas, you will be able to easily identify whether it is north of you or south of you. At the time of meridian passage, the body will either be exactly north of you or it will be exactly south of you. It cannot be in any other direction because the body is on your meridian and the meridian runs in the north-south direction. However, theoretically, when you are solving these questions in the exam, how can we easily find out what is the azimuth of the body? Is it north or is it south? So let me explain that to you in the coming slide. I will tell you with a small, simple, rough diagram. We can easily identify and find out what is the name of the azimuth or in which direction does the body lie. So again, I'm emphasizing that naming the true altitude and naming the MZD is not fundamental. It is not fundamentally done. True altitude and MZD are not given any names. We have just named them to save some time in the question, because by naming them, we were able to find out whether MZD and declination are to be added or one of them is to be subtracted from the other. So in case we don't use this method, then we need to make the rational horizon diagram, which will take some time. So just for the purpose of saving this time, we have used a shortcut method.
Now, beta, before we proceed ahead and go into the naming of the azimuth, you see the full procedure of the Marpas method now, right from beginning to end, with the information as well as what all we are required to find out. So have a good look at it and let me know if there are any doubts in your mind at any step.
सर मेरे को एक डाउट है सर, ये आपने अजीमथ का नेमिंग कैसे कर दिया? जैसे ट्रू एल्टीट्यूड का जो आपने नेमिंग किया वो कैसे कर दिया डायरेक्ट? वो समझ नहीं आया
वो
सर।
मैं अभी बता रहा हूँ बेटा. नेक्स्ट स्लाइड में आई विल शो यू अ डायग्राम एंड आई विल टेल यू हाउ द azimuth is named. I'll tell you. Other than that, anywhere else you have any doubt?
नेगेटिव सर, बाकी समझ में आ गया सर।
वेरी गुड. सो नाउ दो चीज़ें हैं बेटा. एक तो चीज़ ये है, हाउ डू वी फाइंड आउट द azimuth ऑफ द बॉडी? दैट इज़ वन डाउट. सेकेंड इज वाई डू वी नेम द ट्रू ऑल्टीट्यूड सेम एज azimuth? इनमें से तुम्हारा कौन सा डाउट है?
सर ये नेमिंग कैसे किया सर, ये है मेन तो सर डाउट।
Means how do we find what is the direction of the azimuth of the body, right?
करेक्ट, राइट सर।
Okay, I will tell you now how the azimuth is found. एक बार हमें azimuth पता चल जाए, whether the azimuth is north or south, after that it is simple. Whatever is the name of the azimuth, the true altitude will be named same as that and MZD will be named opposite to that. So after that it is clear. Now how do we find out in a question what will be the azimuth of a celestial body? Before I go ahead, beta, if you want to take a screenshot, you can take it. This gives you a summary of the full method. If you have this in front of you, you start from step 1 and you will reach up to the last step, finding the answer. So you can save it and keep it with you. Done, beta?
Yes, sir.
Okay, great. Let's now see the naming of the azimuth.
Now, let me explain to you a easy method how to determine the azimuth of the body theoretically. Now, just draw a simple rough diagram showing the meridian of the observer. So you draw a vertical line which represents the meridian of the observer, and in the middle you show the equator. So you see this horizontal line, it represents the equator. So let's label it as equator here. So vertical line representing the meridian of the observer, the horizontal line representing the equator. Now in this diagram, we are going to fit the celestial body and the observer. How are we going to fit them here? The celestial body is put in this diagram basis its declination. Now let's assume the declination of the celestial body was 20 degrees south. just assuming a figure for understanding. So what we do is from the equator, we go 20 degrees down south and we show the body here. You can see the star shown here in this particular location in the diagram. Now, once the celestial body is there in the diagram, we now fit the observer. The observer is put in this diagram basis the latitude of the observer. So whatever is the latitude basis that you put the observer in this diagram. The DR latitude is available to us in the question. So let's assume that the latitude is given as 30 degrees north. So from the equator, we go approximately 30 degrees north and we fit the observer here. This is just a rough diagram, not to scale, just to understand in which direction the body will be when it is crossing our meridian. So observer is put in this diagram basis his latitude. The body is put in this diagram basis its declination. And you can see clearly now that when the body is on the observer's meridian, it is passing south of the observer. So the azimuth of the body is south at the time of meridian passage. So this is what we use in our shortcut method. The true altitude is named same as azimuth. So in this particular case, the true altitude would be named south and the MZD is named opposite to it. So MZD in this particular case will be named north. And once we know what is the name of the declination, we will immediately come to know whether MZD and declination are to be added up or one of them is to be subtracted from the other. So this is a very simple rough diagram. You can make it in the rough column and find out what will be the azimuth of the body at the time of Marpas.
Beta, I hope it is clear now.
Yes, sir.
नहीं सर, तो
बताओ बेटा क्या डाउट है?
क्या हुई सर अजीमुथ की डायरेक्शन, मतलब इसमें क्या हुआ अजीमुथ का डायरेक्शन?
बेटा डिस्कनेक्ट हो गया था क्या?
तो बीच में से थोड़ा सा इसलिए।
ओके, नॉट एन इशू। ये बेटा रफ डायग्राम दिख रही है एक?
हाँ सर, ये आपने इक्वेटर रख दिया, स्टार रख दिया साउथ में, नॉर्थ में लैटिट्यूड में ऑब्जर्वर रख दिया।
वेरी गुड। सो हमने स्टार को फिट किया एज पर द डेक्लिनेशन ऑफ द स्टार और ऑब्जर्वर को फिट किया एज पर द DR लैटिट्यूड ऑफ द ऑब्जर्वर। ये दोनों चीज़ें हमें क्वेश्चन में मिल जाती हैं, डेक्लिनेशन फ्रॉम द एल्मनैक, DR लैटिट्यूड गिवन टू अस इन द क्वेश्चन। जब हम दोनों को फिट करते हैं, नाउ वी हैव द ऑब्जर्वर, वी हैव द स्टार। You tell me, if the observer looks at the star, in which direction he is looking?
South.
Very good. That is the azimuth of the celestial body.
Okay.
So the azimuth is south. The true altitude will be named same as azimuth. It will be south. MZD will be opposite to it. MZD will be north. Once you know the name of the MZD, you combine it with the declination and get the observed lat.
Okay.
Okay बेटा?
Yes sir.
Okay. और बताओ बेटा, और क्या डाउट है?
सर एक वैसे ही डाउट था, सब बॉडी जब रैशनल होराइजन पे होती है तब ZX 0 होता है ना, ZX 90 होता है ना?
बॉडी जब रैशनल होराइजन पे होती है तो ZX विच इज द जेनिथ डिस्टेंस वो 90 होता है। यस, दैट्स राइट।
और सर उस टाइम पे डेक्लिनेशन कुछ भी हो सकती है ना सर, कोई जरूरी नहीं है ना कि दैट विल बी सेम? और
नो, डेक्लिनेशन तो कुछ भी हो सकती है बेटा,
कुछ भी हो सकती है ना, ठीक है सर।
एनीथिंग। राइट। और बेटा और बताओ डाउट। So is this method totally refreshed in the mind, crystal clear, the Marpas method?
Yes sir, clear.
Okay, great. So अब बेटा इसके बाद जो next method है, the next one which we have is longitude by chronometer. So shall we move on to the second method?
Okay, sir.
Okay.
Yes, sir.
What I'll do is मैं ये दो method आपको करा देता हूँ. I know you must be wanting to practice some questions. Now once these two are done, after that if you want you can practice a couple of questions, maybe one question each, and then we can move on to the next method. Or if you are comfortable, if this seems very much in control, then we can continue to proceed ahead.
सर प्रैक्टिस कर लेंगे बेटर है सर.
Okay. So you want to practice the Marpas now, or shall we do the long by cron and you can practice both of the methods
सर लॉन्ग
simultaneously?
बैक लॉन्ग सर फिर कर लेंगे
बाद में एक
Oh.
साथ
Okay,
बाद में
all right. ठीक है, बहुत बढ़िया. So we will do the long by cron, and after that maybe you can practice a couple of questions. So then once you are comfortable, then I'll proceed ahead to the third method, which is the intercept. So let's move on to longitude by chronometer method now. Now, before I move on to longitude by chronometer, let me clarify one more concept, which is sometime given in the question, and it may make the question a little tricky. So let's see that concept. After this, we will move on to long by chron.
Now, one more trick which is sometime used in the question is, in the side solving questions, is that when they provide you with the date and time, they do not specify what is the date which is given in the question. There are two possibilities for the date. It could be either the local date, the date at the ship, or it could be the GMT date. Now, if it is specified, then there is no confusion at all. If it is specified as the GMT date, we have no confusion at all. If it is specified as the LMT date, and we will use it as such. But in case the date is just mentioned without any indication whether it is the local date, the LMT date, or the ship's date, or it is the GMT date, what is to be done? So to resolve this confusion, always remember the date which is given in the question is always the LMT date or the local date or the ship's date, unless specified otherwise in the question. So the meaning is that we are always going to use this date as the LMT date, local date, or ship's date, unless the question specifically mentions that this is the GMT date. Only in that case, when it is specifically mentioned that this is the GMT date, we use it as GMT. Otherwise, the date is always to be considered as LMT date. A very important point as far as the questions are concerned, because if you get confused with the date and you take it wrongly, you take it otherwise, the entire question will become wrong. So always remember this. The date given in the question is always the LMT date or local date or ship's date, unless specified otherwise in the question.
Okay, all right. This we can leave for the time being, not required for our level. This also can be done later. We now move on to the second method, which is longitude by chronometer. So let's see it in the same way. What all information is provided to us, what is the method which we follow, and how do we obtain the answer. Step by step we will see as we saw in MURPAS.
Let's move on to our second method of obtaining position lines, that is longitude by chronometer. Now, in our first method, which was latitude by meridian altitude or MURPAS, we have seen that by obtaining the altitude of a body at the time of meridian passage, we are able to obtain a position line which matches with the latitude of the observer, and we call it observed lat. Now, the meridian passage method is very quick, easy, and convenient to do. But there is one restriction which the meridian passage method has. And that restriction is that any particular celestial body will come on our meridian or cross the meridian or pass the meridian at only one particular time in a day. Taking the example of the sun, you see sun rises on the eastern horizon in the morning. Then it crosses the meridian around noon time, meridian passage time. It crosses over to the western side of the observer, and then eventually at the evening time it sets on the western horizon. So you see during the entire day the sun crosses the observer's meridian only at one particular time, and we can use the meridian passage method only at that instant. Now, if we want to use the body to obtain a position line before meridian passage or after meridian passage, we need to have some other method. MURPAS cannot be used there. So this is exactly where the next two methods come in. First method is the longitude by chronometer method, and the second method is the intercept method. So these are the ones which we are going to discuss now one by one. Now, first of all, coming to longitude by chronometer. As is clear from the name, this method tells us that we can obtain the longitude of the observer if we have the chronometer. Chronometer basically means GMT. So the name of the method tells us that if we know the GMT and we observe a particular body, or we take the site of a particular celestial body, we will be able to obtain a longitude. So that is the essence or the meaning of the method, longitude by chronometer. Now, one important thing to remember here before we proceed into the method, that the longitude which we obtain is not the fixed longitude of the observer. So obviously a doubt will arise in your mind, then what longitude it is. I will explain it to you once we reach up to the diagram of this particular method. The longitude is where the PL cuts the DR latitude. So it will be clear to you once we complete the procedure and we draw the diagram that this longitude is not the fixed longitude. So anyway, first of all, let's see what all information is provided to us in these type of questions, and what is the method, what is the formula which we use to obtain the position line. Now, first of all, let's go into the information which is provided. The info provided in these questions is the date and time of observation, the time may be given as GMT straight away, or they may give us the chronometer time. Obviously, if the time is given as chronometer time, it will have the chronometer ambiguity, and we will need to resolve the chronometer ambiguity. So for the chronometer ambiguity, a AM or PM indication is given to us in the question. Now the second information which is provided to us is the sextant altitude of the body. Along with the sextant altitude, they give us the index error and the height of eye. Both of these are required for altitude correction. And the third thing which is provided in these questions is the DR position, the DR latitude and the DR longitude. So this is exactly all the information which is available to the navigator when he takes a site. He will be able to find the exact date and time when the site is taken. He will be able to get the sextant altitude of the body. He will know what is the index error of the sextant. He will know what is my height of eye in this particular condition of loading. And he will also know what is the DR position of the ship. So this is the information which is given to us in the question. Now, how do we proceed ahead? Now, the first thing which we do is, if it is chronometer time, we resolve the chronometer ambiguity and we get the exact GMT date, hour, minute, and second. Once the exact GMT is available to us, we enter into the almanac, and for that particular body, we get the GHA of the body. We get the almanac information out. So when you look for GHA on the daily page, you will be able to find out the hourly GHA, and from the increment table, you will be able to find out what is the increment for the particular minute and second of the time which is given to us in the question. And if the body requires a V correction, the planets and the moon, they both need the V correction also. So we can get the value of hourly V correction from the daily page, and we can get the increment from the increment table under that particular minute for which the GMT is given. So the V correction increment is also picked up if required for that particular celestial body. And once you combine all three of them, increment is always added, whereas V correction could be plus or it could be minus. It is negative only for one planet, that is Venus. It could be negative, it could be positive. However, in most of the pages in the 1992 almanac, selected pages which we have, the V correction for Venus is in negative. For all other bodies, the planets Mars, Jupiter, and Saturn, as well as the moon, the V correction is always positive. So increment is always added and V correction is applied as per the sign. And once you do that, you will get the accurate GHA of the body. So this is the first step. We obtain the accurate GHA of the body. Now, once we have the GHA with us, we also have the DR longitude known. DR longitude is given to us in the information. So when we apply this DR longitude to the GHA, we get the LHA of the body. So we find out the LHA of the body. Now with this LHA, we write the word approximate. So you can put a bracket and write along with that LHA as approx or approximate. Now, why are we indicating as approximate? The reason for that is that we have used the DR longitude to obtain the LHA. Now, DR longitude could have errors in it. So that's why the value of LHA will not be accurate. The GHA was exactly accurate for that particular date, hour, minute, and second. However, there could be an error in the DR longitude, giving an error in the LHA also. That's why we have written approximate here. The second reason is later on in the question, we will be finding the exact LHA also. And just to distinguish between the two, we have marked it as approximate. Now, once LHA is known, then we go into the almanac again The second information regarding the body which is given in the almanac is the declination. Now from the daily page, from the date page, we will be able to get the hourly declination for the particular GMTR. We will also get the value of D correction from the daily page itself. And when we go into the increment table, we can find out the increment for the D correction for that particular minute which is given in the GMT. Once applied, it gives you the accurate declination of the body. So we have obtained the GHA, approximate LHA, and the declination of the body. That is step 1. Now moving on to the next step. The next information you see we have is the sextant altitude. We will correct this altitude now. We will first apply the index error. If it is on, you put it off. If it is off, you put it on. Then we apply the height of I using the dip correction. The dip correction is always negative, obtained from the table given on first page of the almanac. And once these two corrections are applied, we obtain the apparent altitude of the body. With the apparent altitude, we can now enter into the almanac and obtain the total correction for the body. We are familiar with the total correction table of sun, stars and planet as well as moon. So we apply the total correction to the apparent altitude, and once applied, it gives us the true altitude of the body. So this is step number 2. So we obtain the true altitude of the body. Now, once we obtain the true altitude, GHA and the declination, we are now ready to apply the Long-Bicron formula. What is the Long-Bicron formula? The Long-Bicron formula says cos of P. This is the same P which we saw in azimuth calculation in the ABC method. So P is basically angle P of the PZX triangle, and it is derived from the LHA of the body. It could be equal to LHA or it could be equal to EHA or 360 minus LHA. So cos of P is equal to sine of true altitude minus plus sine of latitude multiplied by sine of declination whole divided by cos of latitude multiplied by cos of declination. Now a couple of things in this formula. P, as I already told you, is obtained or is the same as we used in the ABC method. P is either equal to LHA or P is equal to 360 minus LHA. In this case, we are going to calculate the value of P here in this formula. The true altitude, first term is sine of true altitude. The true altitude is already known. We have corrected the sextant altitude and obtained it. Then we see a minus plus sign. Now, what does this minus plus indicates? It indicates that in this formula, we will either use a minus here or a plus here. Now, which one of the two symbols is to be used? The upper symbol in these kind of equations, upper symbol is always used when the following terms, that is latitude and declination, are of the same names. And the lower symbol is used when the following terms, that is latitude and declination, are of the opposite names. So in this particular case, when latitude and declination are of the same name, we will be having the upper sign, which is a minus in this case. And when latitude and declination are of the opposite names, we will have a lower sign, and that is plus. The latitude used in the formula is the dr latitude. Dr latitude is available to us as dr position is known. Then we have declination. Declination has been calculated from the almanac information. We have the accurate declination with us. In the denominator, again, we have the latitude for which we use the dr lat and the declination which is known to us. So you can see in this formula, all the terms which are there on the right hand side are known to us. So with all these terms known, we put them into the formula, and with a single step calculation in the scientific calculator, we will be able to obtain the value of P. So we calculate the value of P using this formula. Now this is a very important formula. It is to be memorized by heart. So please memorize this formula. The only way this question can go wrong is if you apply the formula wrongly. Otherwise, the question is pretty straightforward, straight and simple. Now, once you obtain the value of P from this formula, from this value of P, now we can obtain the exact or accurate LHA. See, we calculated the LHA using the dr longitude also, but that was approximate. Using this value of P, we can now calculate the exact or accurate LHA. Now, when we find out LHA from P, one doubt which is going to arise in our mind is whether P is equal to LHA or P is equal to 360 minus LHA. Now, this doubt does not arise when we find the value of P from LHA, because we know when LHA is less than 180, P is equal to LHA. When LHA is more than 180, P is equal to 360 minus LHA. But in this case, the value of LHA is not known to us in the first place. So we don't know whether P will be equal to LHA or P will be equal to 360 minus LHA. So how to determine? Now this is where the approximate LHA comes to our use. Now you have a look at the approx LHA. If the value of P is close to this approx LHA, that tells you that P will be equal to LHA. And if the value of P does not match at all with the approx LHA, you do 360 minus P, and you will see whatever answer you get, it will match with your approx LHA value. Usually 90% of the questions, this will be within a degree. That means whatever LHA you have calculated, you will get one of these values, either P or 360 minus P, within a degree of the approx LHA. So it immediately gives you an indication whether P will be equal to LHA or P will be equal to 360 minus LHA. So repeating once again, whatever value of P is obtained, compare that value with the approx LHA. If both of them are matching or they are close to each other, you take P equal to LHA. And if both of them are not matching, you subtract P from 360, get 360 minus P, and you will see that that value is going to match up with the approx LHA. So this tells you that in this case, LHA will be equal to 360 minus P. So this is how we obtain the value of LHA from the value of P. Now, once LHA is obtained, we have the accurate LHA now, which is calculated using the Long-Bicron formula. We can now compare this LHA with the GHA of the body. The GHA of the body has been already calculated earlier, found out from the almanac. So you compare this accurate LHA or the exact LHA with the GHA of the body. And when you compare both of them, their difference gives you the observed longitude. The difference between GHA of a body and the LHA of a body is determined by the longitude of the observer.
Beta, just give me a couple of minutes. There's an important call, so just wait for some time. Okay, beta, let's continue. I am stretching into your break, but once this is completed, then we will have our break. Huh? The next session is also mine, so we will continue.
So when you have both LHA and GHA known to you, you will be able to easily find out the longitude from their difference. Now this longitude which you obtain from the difference of GHA and LHA is called as observed longitude, because this longitude has been obtained by observing the body or by taking an observation of the body, which we call as sight. So we have obtained the observed longitude here. This was the name of the method, longitude by chronometer. Now, as far as the position line is concerned, only finding the observed longitude is not sufficient. We also need to find out the direction of the position line. We have a reference point now from where the position line passes, that is the observed longitude, but we also need to know what is the direction in which the PL lies. So for that, we need to calculate the azimuth of the body. In case of celestial bodies, the position line of the body, position line obtained from the body, always lies perpendicular to the azimuth of the body. So always remember, in case of celestial observation, the azimuth of the body is always perpendicular to the position line. So if you want to find out the direction in which the position line lies, find the azimuth of the body and perpendicular to it, 90 degrees away from it, is where the PL will pass or lie. How do we get the azimuth of the body? Now for the azimuth, we use the ABC method. We are aware in the ABC method, A is equal to tangent latitude upon tangent P, named opposite to latitude if P is less than 90, and named same as latitude, that is unusual cases, very few cases. It is named same as latitude in case P is greater than 90. So after A, we obtain the value of B. B is equal to tangent declination upon sine of P. Declination is known to us. The value of P is also known to us. We have calculated P using the formula. Same way for A, the latitude used is the TR latitude, which is available in these questions, and the value of P is obtained from the formula. So B, once calculated, is named same as declination. And once we get A and B, combining A and B together gives us the value of C. By combining, I means they could be added or subtracted. If they are both of the same name, both are added up and the name is retained. And if they are of opposite names, then the smaller value is subtracted from the bigger value and the name of the bigger one is retained for C. Once C is obtained, we put it into the formula of tan azimuth is equal to 1 by C into cos of latitude. So we have the value of C now obtained from A and B, and we have the latitude which is given to us in the question. So using these two, we obtain the azimuth of the body. This azimuth is in the quadrantal notation. We obtain the quadrant using the name of C and the value of LHA. So once the azimuth is obtained, we are aware now that a celestial position line is always perpendicular to the azimuth of the body. So adding and subtracting 90 degrees gives us the direction in which the position line lies. So we have obtained the direction in which the PL lies, and we have also obtained the observed longitude. These are the two items which are required in these questions. And when we have these two items known to us, we are able to plot this position line easily on the chart. You have a reference position, which is given by observed longitude. And what about the latitude? The latitude used is the DR latitude only. DR latitude and the observed longitude gives us the reference position from where the PL passes, and the azimuth gives us the direction of the PL because we know that PL is always perpendicular to the azimuth of the body.
So beta, this was the complete method of longitude by chronometer, right from beginning to end. We have the information, we have the stepwise procedure, and we have the final result, the observed longitude and the direction of the PL. So have a good look at it and let me know if you have any doubts at any of the steps, anywhere. If you have doubts, let me know. Okay, so is it okay, beta? All okay? If you want, you can take a screenshot and keep it with you. This gives you a summary of the full procedure. Okay, so shall I close the presentation now, beta?
यस सर. सर वो ग्रुप में जो डाउट था सर वो एक बार ऐसे ही बता देंगे, चाहे हल्का से, जस्ट मतलब विदाउट डायग्राम और कुछ, जस्ट वर्बली.
ओके ओके, सो अब बेटा पहले तो ये जो दो मेथड हमने किए हैं, अब आफ्टर द ब्रेक यू कैन गो फॉर ए ब्रेक नाउ, एंड आफ्टर द ब्रेक you can practice maybe one question of each of them. Marpas, you can do a question of sun, and long by Crone you can do a question for any body, sun, star, planet, moon, and you can practice these two methods. So once you are comfortable with these two, then I will move on to the next ones, intercept and X meridian. So that is the plan going ahead. Okay. अब नेक्स्ट थिंग, हाँ बोलो चेतन, क्या बोल रहे हो?
नहीं सर, ओके सर बोला. वो डाउट क्या कह रहा था सर, वो एक बार बस आप क्वेश्चन पढ़ लीजिए चाहे एक बार.
जो क्वेश्चन नंबर 7 है बेटा.
हाँ सर, एक बार.
Okay, what you do is you take a break now, and we meet back whatever time you tell me. We will meet back and then we will discuss that question.
ओके सर. आप बता दो सर कितने बजे बाद.
What time would you come back, beta? 1300?
ओके सर.
Okay, all right.
Yes.